Okay, so you should have your packets and you should have the yellow paper from the door. Everybody have the yellow paper? Caleb, yellow paper? Okay. So the packets and the yellow paper. So we're going to do the yellow paper first. One thing I want you to realize is next Wednesday is a PSAT. Is anybody taking it? Okay. So next Wednesday is going to be kind of a catch-up day for those of you that will be here. Okay. So anything you're missing or anything you need help on or anything like that, that's what that day is going to be. Okay. For those of you that are not taking your PSAT. Monday, no school. Yay.
What's Monday?
It's just a professional day. You know when the elementary teachers do the parent-teacher conferences? That's what day that is. But we don't do parent-teacher conferences, so we all get a break. Yeah? Okay. So realize that not next week or the week after that is your test, your next test. Okay? So it's over what we've been covering and then what we're starting today. Okay? So I might want to unfreeze it. We're going to get started. So looking at this, our first function we're talking about is the absolute value parent function. So if you have to keep this yellow paper. If you notice, it even says keep me. This is not something that we're done with after this unit and you're done with this packet. This is something we're going to continuously do. So it should stay in your folder. And yes, stay in here. Yes? Okay. So first things first, we're just doing absolute value today. So everybody should have a calculator. We finally get to use our calculators. So I'm going to teach y'all how to graph your absolute value. So you go to y equals. You're going to hit math. You're going to go to the right and hit where it highlights num for number.
Whoa.
You see how number 1 says abs? That's for absolute value. You press enter. Now do you see how it has the absolute value lines?
Wait.
So you'll put an X. Can you repeat? Yes, I can repeat it. Okay, so I'm going to clear it. So go to y equals. You're going to hit math, right, enter. Math, right, enter. And these should show up. So you just put an X in there. Okay, because that's all we're doing right now is the parent function. So this is the parent function. So if I hit graph, this is what it looks like. Okay, so my parent function equation
Whoa.
is y equals absolute value of x. They're not ones. Okay, I had one student that was like 1x1. What's that? It's not ones. They're lines. Okay. Absolute value just means cancel the negative. That's why this looks like a linear line. But then what happens to it? When it starts to go negative, what does it do?
It
Jumps back up.
positive.
Okay. So looking here, I'm just going to put a couple numbers in my table. -2, -1, 0, 1, 2. It starts at 0, 0. That's my x-intercept and my y-intercept. And it goes up 1 over 1 to the positive side. So that's the side that's like linear. And then it goes up 1, left 1. Does anybody remember the word vertex? From quadratics. Do you remember the word vertex? Okay. This point, the 0, 0, is kind of like our vertex. Okay. So I'm going to finish plotting my points. -2 is +2. -1 is +1. Do you see how all my y's are positive? Okay. Now, what do you think the domain is? First off, domain is your width, right? It's how wide it is. What do you think your domain is here? Does this ever quit getting wider?
Yeah,
No. So it literally goes from -infinity to +infinity. Okay? That's that's interval notation. If I wanted to do set notation, guys, you can just say all real numbers. Okay. Any questions so far? Are y'all okay with that domain? So confused. What are you confused with? The calculator part, how to put it in your calculator? So you're just going to come here and you hit math. Go to y equals. hit math, go to the right arrow, you see how it says ABS, go hit enter, and there it should be there. And you'll just type X in the middle and hit graph. Okay? So now my domain. Domain is your height. What's my height here, guys? What? That's the fancy R that means all real numbers. Okay? What about my range? What about my height? Does this go down forever? No. What's the lowest it goes?
0.
0. And now is that going to be a bracket or a parentheses?
Bracket.
Bracket. Why?
Because it's a closed circle.
Because it touches that point. It's a closed circle at that point. Okay? And it goes all the way when? When does it stop going up?
The 10.
Never. It keeps going forever. So it goes to infinity. Okay? Okay, the way to write this in set notation is just y is greater than or equal to 0.
Is that infinity parentheses?
Yeah, parentheses of infinity always has a parentheses. Because the 0, because you'll never actually touch infinity. Yeah. What's my x-intercept?
0.
0, 0, right? What's my y-intercept? Same thing, 0, 0. Okay, if you had to describe this graph, what would you say? If you had to describe what it looked like, what would you say?
A V.
A V. It's V-shaped. Okay, the way I always remember is absolute value. Value starts with a V, and it's V-shaped. Okay, it's the only parent function that has a word that starts with V, so it's the only one that looks like a V. Okay, absolute value means V. Okay, and then your calculator steps, what did we do? We hit math. Then what? Then the right arrow. Then what? We hit enter. Okay, the reason we hit enter is because it had a number 1. Had a number 1 and it said ABS with a parentheses for absolute value. Okay. You could also hit math right 1 because that's why the absolute value had that number 1 in front. Okay. Any questions when we talk about the parent function? Okay, so we're done with this paper for right now. And we're going to open up our packets to worksheet 5. So when you're done writing this down, no rush, open up your packets to worksheet 5. Alright, so guess what? We're literally just going to graph the parent function again. So, where did it start? At 0, 0. And remember, it went up 1 over 1. Okay, it tells me my equation of the original. Okay. When it has the table, there's not specific points. There's a bunch of points. Do you have to write every one of those points? No, I've just kind of stuck with the -2 to +2. Okay. Okay, we talked about how our domain went from -infinity to +infinity because that's our width. What's your question?
I can't draw that.
Uh-oh. Okay, and then it goes from 0 all the way up to infinity because it never stops going up. One thing I do want you to realize is that domain goes from left to right, smallest to greatest, and range goes from bottom to top, lowest to highest, okay? So I've seen a lot of like backwards domains or backwards ranges. So make sure you're going from smallest to biggest, negative to positive, okay? Any questions about this? We really just kind of repeated what we just wrote on our paper, right? Yeah. So guess what we're still working with? Yes? Just the X. Yeah. Okay. So we're still working with I hat over. So over there on the wall. Okay, it's still there. Caleb, put it away. Okay, I hat over. Inside is our horizontal. It's opposite, and it's your domain. While outside is vertical. It's exact, and it's your range, okay? So up is plus, down is minus. Now, what if it's multiplying? Are you shifting up and down? No. What did multiplying mean? Most of the multiplying we did was outside, right? Which meant it was vertical expansion or compression, okay? But we're going to get started. So looking at number 1, what do you notice? Is it an inside change or an outside change?
Inside.
Inside change. And what changed?
The X minus.
So we know it's an I hat change, which means it's horizontal, okay? And it's doing what? What's it have in there? You said it.
-1.
It's -1. What does -1 mean? Inside.
Zero.
Inside. So it's a horizontal change.
So it's going
So it's
inside.
actually going to go to the right one, right? Yes? No? Maybe so?
Yes.
So we're going right 1. Now, do you notice that our parent function is not on there? Okay, you'll always start. Do you remember what I labeled the vertex? The point of the V? That's where you start. So where was the original point of the V?
0, 0.
At 0, 0. So what does this tell me to do?
Move right 1.
To move right 1,
And then do it.
there's my new vertex. So guess what? I do the same thing. I go up 1 over 1, look for my new vertex. Does that make sense? No? Yes? We literally just shifted the vertex over 1. Now, technically, you don't have to graph the parent function, but I'm going to really fast. If I were to graph the parent function, see I'm doing it in a lighter color. Did it just shift over 1? Did everything move right 1?
Yes.
Yeah. If you feel like you need to graph the parent function first, that's fine. Just make sure you do it to where it's obvious which one's which, okay? Yes.
So those 2 lines don't mean anything?
What 2 lines? Those 2 lines on the outside of the X mean to cancel negatives. That's why instead of going down to negative Y's, it pops back up to positive. So like if you look at the original,
stay above?
not always. What if there's an outside change? Outside change can still shift it up or down. Okay? So if you look here, do you see how the -2 became a +2? -1 became a +1? And then all the positives stayed positive? Okay, that's all those lines do. Okay, so what's my domain here?
Oh, -1. -1.
Negative infinity to infinity.
Oh.
It's still getting wider. Right? Those arrows at the end tell us it's never going to quit getting wider. Okay, what about my range? Did my range change from the original?
No.
No, it's still down at 0 and still goes up to infinity. So to fill in our table, -2 is +3, -1 is +2, 0 is 1, 1 is 0, and 2 is 1. So I want y'all to try number 2. Okay? You are trying number 2. Okay, so walking around, it looks like all of y'all did it right. So what is this telling me? What's my change? Is it inside or outside? It's inside. So it's an I-HOD change, which means it's left to right, and it's positive. So which way do I go? It's opposite.
Right.
So to the left. Okay, so this tells me I'm transforming left to. Whoever's volume on, please turn it off. So I'm literally from my original vertex going left 2. And there's my new vertex. And then I just do my up 1 over 1. Now, I did see one person doing this, which is totally perfect. Guys, what's different with this versus what we were doing before? I'm given an equation, right? I'm given an equation. Can I type that in my calculator? Guys, yeah, you can check every single one of these in your calculator. So that's my parent function. I always leave the parent function, and if you see how I went all the way to the left and made that kind of look like a windshield wiper, you press enter, you see how now it's thicker? Okay, and then I'm going to come down, and I can type this new one. So math right, enter, x plus 2, and I can go to my graph. There's the original. There's the new one. Did it work?
Yes.
Yeah, does that match?
Yes.
Yeah, now I can also go to my table. Just be careful because I left the original in there. So y1 is the original, y2 is the new point. Do we have 0, 2? 0, 2?
Yes.
Yeah, we do. Okay, so we can also use this to find our new table. So I'm going to stick with the -2, -1, 0, 1, 2. And that gives me 0, 1, 2, 3, 4. Okay. So what's my domain? Did it change? No. Still goes from negative infinity to positive infinity. Do you think any of their domains are going to be different today?
No.
No, because all of them are always going to keep getting wider. Guess what? The only time it won't be all real numbers is if I have like a story in there with it. Okay? But these are all just functions today, so all of their domains are going to be all real numbers. Now the range might change. Not often, but it might. It actually is going to be mainly the only thing that changes today. So the range here today is still from 0 to infinity on this problem. Any questions on number 1 or 2? So let's look at number 3. What do you notice?
Is it plus 3 outside?
I have 2 changes. So what do those 2 changes mean?
Up 3.
One of them means up 3. What's the other one mean?
Left. Left.
Sorry, I'm not.
Left 3. Is it a jacket? Take the cardigan.
Okay, so we have an inside change, and we have an outside change. Okay, what is that inside change telling me, that plus 3?
Left. You go up 3.
The inside change.
Oh, left 3.
Left 3.
The outside is up 3.
And what's the outside change mean? It's outside, so it's vertical. It's exact, so am I going up or down?
Up 3, bro.
Up 3. So my original vertex was at 0, 0, and which way do I need to go?
Left.
Left 3, 1, 2, 3, and then what?
Up 3.
1, 2, 3. Where's my new vertex at?
3, 3. Negative 3, 3.
Negative 3, 3. And then it's still open upwards. Nothing told me to flip it. So there's my new graph. So again, I can type it in here. As a plus, not 23. And I can check it. There's my original. There's the new one. Did it change?
No, ma'am.
Like it was supposed to? I'm going to delete the original, actually. Do y'all see it? Does that match what we did?
Mm-hmm.
Yeah. And again, we can come to our table to get our points. So, negative 2, negative 1, 0, 1, 2. And what is it? Negative 2, it was 4, 5, 6, 7, 8 from the calculator.
Okay.
Okay? So what's my domain?
Negative infinity to infinity.
What's my range?
3.
Did it change?
Yes.
Yeah, it's the height definitely changed. Okay, so it's from 3, positive 3, right here, to all the way up to infinity. It never stops going up. So 3 to infinity, with 3 being a bracket because there's an actual point at 3. That point is included in the graph.
So 3 is the new starting point.
So 3's are, yeah, 3, 3 is where, or negative 3, 3 is where our vertex starts.
Oh.
So now you're trying number 4. You are trying number 4. Okay, everybody looks like they have it right. Okay, so what did we do? We have an inside change that tells me to do what? Right, how many? 1. And we have an outside change that tells me what? Down 2. Okay, so from my old vertex, I'm going to go right 1 and down 2. And there's my new vertex. Did anything tell me to flip it? No, so it's still up and upwards. So this is what everybody should have. And what do we notice? What's at negative 2? 0, 0, negative 1. Okay, one thing I want you to realize now is, does the y have negatives? Yes, but the only reason y has negatives is because there was an outside change of down 2. Okay? It will never have negatives unless there's a shift down or it's flipped. Okay? Yes. Okay, so domain, did it change? No, it's still getting wider forever and ever. What about the range? Did the range change? What is it? Negative 2 to what?
2.
infinity. With a bracket. Any questions? Okay, flip to the back. Here's where things start to change. Get a little more difficult. Could you use your calculator?
Yes.
Yeah. Guys, don't make these hard. Okay, so which one do you want me to do?
The 5. No, wait. 8.
7. 8.
Okay, we're not going to do number 7 today. Don't cross it out, because that doesn't mean we're not going to talk about it. Okay? Go ahead and circle number 7. You don't have to do it, or just put an X on the number and on number 14. We're not going to do those today. Number 7 and number 14. We'll do those another day. Okay? So I'm actually going to do, I'll do number 5. Number 5, what's it telling you?
Vertical flip.
It's outside, so it's a vertical flip. Okay? One thing I want you to notice on number 6, there's a negative inside. What do absolute values do?
Horizontal.
They cancel negatives. So does that negative change anything? No. If you graph it, all this should do is shift up 2. Okay? And make sure that's right before I say that out loud too. Or down 2. Wait. Haha. I did my key wrong. It should go up 2. I'm losing my mind. Okay? It should go up 2. Any questions on these two? Okay?
Maybe it should go up to.
On number 6, because it has that outside, that vertical change of +2. Okay, let's do number 8, and then I'm going to let y'all practice. What's number 8 telling me? I have an outside change,
Vertical compression.
a vertical compression, exactly, and an inside change. So I have a vertical, I'm just going to do V, compression, by a half, and what's that other change? What's that inside change tell me?
Left one. Down.
Left one. It's inside, so it's a horizontal. It's a left to right change. Okay, if y'all look over there at the IHOD poster, do y'all see I have a plus sign on the left and a minus sign on the right? Thanks, Jim. Okay, and if you look on the outside, the over poster, I have a plus sign on top and a negative, minus on the bottom. That's how it tells you which way to go. Okay. So what are we gonna do? So what do I do with this center? Which way am I moving?
To the left.
Left 1. There is my new vertex. Now, normally I go up 1 over 1. I'm changing vertical, which is how much I go up. What is half of 1?
0.5.
A half. So guess what I'm going to go up now?
0.5 up.
A half 1 over 1. A half 1 over 1. A half 1 over 1. What do you notice about the graph? It's good. Yeah, it looks wider. It's less steep, right? The two sides are less steep. Up a half over 1. If this confused you, could you have just typed it in your calculator?
Yes.
Yeah. Okay, this is what it should look like in our calculator. Did the domain change?
No.
No. Did the range change?
Yes. No.
Not from the original.
No.
Okay. So it's still just here at 0 to infinity. Okay. But when I fill in my table, -2 is up a half. -1 is up 0. 0 is up a half. 1 is up 1. No. Yeah. And 2 is up 1.5. Okay. Okay, I want you to realize that this is going like up 1 over 2. If I wanted a pretty slope, it's going up 1 over 2. Isn't 1 over 2 a half? Yeah, 1 over 2 is a half. Okay? So, look at the bottom of this paper. All it's going to do now is to work backwards. Okay, you're not doing number 14 right now, but don't cross it out. We'll talk about it later. Okay, and then again, you're not doing number 7 right now. Don't cross the whole thing out. We'll talk about it later. Okay, but I want you to try to work backwards. Yes? Do y'all understand what to do on these? It tells you the change, kind of like the assessment yesterday, and you're coming up with a new equation. Okay, so for the rest of the period, this is what you are working on. Y'all only have